So we're going to talk about measure of dispersion. So the measure of dispersion, or the spread of a data set, can provide useful information. The range of a data set is the difference between the largest and the smallest data values in the set. So in example 1, we're going to compare heights. We're going to find the range of the heights of the people listed in the table. So we're looking at Robert Wadlaw, who's the world's tallest person, Tim Tebow, Madge Bester, the world's shortest woman, and LeBron James. So if we're looking at the range, we really just care that we have a tallest and a smallest. So our tallest person is 8 feet 11 inches, or 107 inches. And we're going to go with just the inches category rather than trying to do the feet in that. And our smallest person is 26 inches. So to find our range, it's going to be the tallest minus the smallest, whatever our data set is. So in this case, it's going to be 107 minus 26, and that'll get us 81 inches. So the heights range from 26 to 107 inches, which is a range of 81 inches. Alrighty. So range is generally not a useful measure of the spread of a distribution because it can be influenced by a single outlier. For example, the range of the distribution of 2, 2, 2, 2, 3, 4, and 100 is going to be our largest of 100 minus 2, which is our smallest, which is 98. Well, that's nowhere near most of the data set, so it's really not going to be of any use. However, standard deviation is a way to find the spread of data, which is a measure based on calculating the distance of each data value from the mean. So we're going to look at how it deviates from the mean. It's called the deviation from the mean. If x is a data value in a set whose mean is x bar, which we've seen in the last section, then x minus x bar, remember x bar is the mean, it's called x's deviation from the mean. And to illustrate the deviation from the mean, we can consider the distribution A of 16, 14, 12, 21, and 22. If we add those together and divide by the 5 digits we have, we would find their mean is 17. So we can list the deviation of each data value from the mean inside of our table. So if our data value is 16 and our mean is 17, well, 16 minus 17 would get us a negative 1. That's the deviation. 14 minus 17 would get negative 3. 12 minus 17 would get negative 5. 21 minus 17 would be a positive 4. 22 minus 17 would be a positive 5. And then the total will be 0 because they should have a balance of distribution from the mean. It might seem reasonable to measure the spread in A by averaging the deviations from the mean in the table. However, that doesn't work. As you see, for scores above the mean that have positive deviations from the mean, there must be scores below the mean that have negative deviations from the mean. When we add them together, they'll cancel each other out, giving a total of 0. We can kind of see what's going on here. Here's our mean of our data, and here's the standard deviations away from it. To avoid the cancellation, we square each of the deviations as shown in the table. So now this is the same thing we just looked at, but now if we square that, we'll get all positive numbers. So the square of negative 1 is negative 1 times negative 1 gets us positive 1. Negative 3 squared will be positive 9. Negative 5 squared is positive 25. 4 squared is 16. 5 squared is 25. So that's where we can look at those and use that to figure more out. Now we'll use this data value here, the deviation squared, goes into our standard deviation formula. So the standard deviation is of a sample of n is denoted by S is equal to the square root of, there's our summation symbol again, means we're going to add them all together, of x minus x bar squared, and then we'll take away one of our values of n. So you figure out and you set up the table, you take this part, this will go, we'll total these up and put it here and then divide by 1 less than that. So to compute, we're going to just do the same steps we did up here. So let's actually go find the standard deviation. So we're going to find the standard deviation of the cost of plane flights, not fights, while planning for spring break. Suppose you went to orbitz.com to find the cheapest flight from Philadelphia to Orlando and found the following prices. We want to find the standard deviation of this data set. Alrighty. So we're going to build us a little chart here. First of all, we're going to have to find our mean. So this will be example 2. So the first thing we need to know is our x bar. That's our mean, and we're going to add up all our data set and values. So we have 195 plus 213 plus 208 plus 219 plus 210 plus 215. We have 1, 2, 3, 4, 5, 6 flight prices. So if we add the first part together, we will get 1,260 divided by 6 will get us 210. So that's our x bar. Now we're going to create the same kind of table that we just saw. So we're going to have our price, which is our x. We'll have our deviation from the mean, which is going to be our x minus our x barred. And then we'll have the deviation squared. So that'll be our x minus x bar squared. Alrighty, so our prices are 195, 213, 208, 219, 210, and 215. And now what we're going to do is take our x and subtract our x bar. So 195 minus 210 will get us negative 15. 213 minus 210 will get us 3. 208 minus 210 will get us negative 2. 219 minus 210 will get us 9. 210 minus 210 will get us 0. And 215 minus 210 will get us 5. Now what we're going to do is square each of these values. So negative 15 squared will get us 225. 3 squared is equal to 9. Negative 2 squared is equal to 4. 9 squared is 81. 0 squared is 0. And 5 squared is equal to 25. Now what we need to do is we have to find this part right here, which is the summation of x minus x bar squared. And we need that value for our standard deviation. So as we add all of these values here together, we'll get 344. So now what we'll do is figure out our formula. So recall that S is equal to that square root of the summation of x minus x bar squared all over n minus 1. All right, so this will be the square root of 344. The number of terms we had, we found up here in our mean, so that will be 6 minus 1. So that'll be the square root of 344 divided by 5, which will be the square root of 68.8, and that'll get us 8.29. So that is the standard deviation. And that would be our final answer.